Have you ever wondered what happens after a dramatic space rescue? The world celebrated the safe return of the Shenzhou 20 crew, but behind the scenes, a whirlwind of technical investigations, tense political discussions, and new discoveries about the dangers lurking in Earth's orbit was just beginning. Today, we continue the story. We're digging deeper into the aftermath, the unknown details, and the long-term impact that the Shenzhou 20 rescue had on global space operations. When the three Shenzhou 20 astronauts were flown back to Beijing for medical checks, engineers and analysts at the China Manned Space Agency were already working nonstop. Their first mission was to determine exactly what piece of debris struck the return capsule, and whether more fragments were still threatening the Tiangong space station. Space debris incidents aren't new, but this collision raised an alarming question. Was this debris part of a breakup event no one had detected yet? The answer was crucial. Within hours, China began collaborating with several international tracking networks to identify the culprit. This is where the story gets really interesting. The object wasn't recent. It was a decades-old fragment, believed to belong to a long-abandoned weather satellite that had gradually fallen into an unstable, decaying orbit. Think about that for a second. A piece of space junk from the early days of the space race, silently tumbling through the void for decades, finally crossed paths with a modern-day mission. Over time, tiny fragments like this drift unpredictably, becoming invisible bullets traveling at over 25,000 kilometers per hour, a disaster waiting to happen. But here's something that wasn't released publicly during the rescue. The Tiangong space station itself had to perform an unplanned maneuver during the crisis. Sensors detected additional microfragments dangerously close to the station, forcing mission control to adjust Tiangong's orbit to avoid a second potential impact. It was an incredibly delicate balance. Any maneuver made docking more complex for the incoming Shenzhou 21 rescue ship, but the alternative, risking the station and everyone on board, was far too great. This tense moment quietly demonstrated something groundbreaking. China's space station now possesses a faster, more automated collision avoidance system. This isn't just a simple software update. We're talking about a system that uses artificial intelligence to predict debris paths and recommend evasive actions in near real time. This upgrade had been tested before, but the Shenzhou 20 emergency pushed it into real-world, high-stakes use for the very first time. It performed flawlessly, a silent hero in this unfolding drama. Meanwhile, inside Tiangong, the Shenzhou 20 astronauts faced challenges nobody saw on camera. With their return capsule disabled, their stay aboard the station was unexpectedly extended by several days. This meant immediate ration adjustments, revised sleep schedules to conserve resources, and new psychological protocols to manage the immense stress of being stranded in a confined environment. Hundreds of kilometers above Earth, mission logs, which have since been partially declassified, show that the crew conducted supplemental medical tests during this period. They were collecting invaluable data on how human bodies and minds handle sudden, high-pressure scenarios in microgravity. This data isn't just for academic papers. It will directly influence how China plans and equips its upcoming deep space missions to the moon and beyond. Every challenge became a learning opportunity, but perhaps the biggest story of all unfolded after the astronauts had landed safely back on Earth. The damaged Shenzhou 20 return capsule itself became a crucial piece of evidence. Engineers retrieved it from the remote landing site and immediately launched a comprehensive forensic analysis. They treated it like a crime scene, meticulously examining every scratch and dent. What they discovered surprised even veteran spacecraft designers. The debris fragment had penetrated deeper than their models had predicted, coming dangerously close to a critical wiring harness. We're talking mere centimeters from triggering a much larger, potentially catastrophic failure that could have compromised the entire capsule. It was a sobering reminder of just how thin the line is between success and disaster in space. This shocking discovery has already influenced the design of future Shenzhou capsules. Reports suggest that starting with the Shenzhou 24 mission, China will add an improved micrometeoroid shield layer. This new design is similar to the Whipple shields used on the International Space Station, a kind of multi-layered Space armor designed to break up and disperse incoming particles before they can reach the main hull. The lesson was learned and the hardware is being upgraded. On the global stage, the incident sparked urgent new discussions about space debris regulation. In the weeks that followed, China, the United States, and the European Space Agency quietly engaged in several joint meetings focused on better tracking and mitigating hazards in low Earth orbit. Although political tensions on the ground remain, the Shenzhou 20 crisis reminded everyone of a simple, undeniable truth: space is too dangerous for nations to operate in isolation. When debris threatens one spacecraft, it threatens all of them. The orbital environment doesn't recognize national borders. This shared vulnerability has, paradoxically, become a powerful catalyst for cooperation. And now, let's look toward the future, because the changes are already happening. As preparations for the next mission, Shenzhou 22, progress, China is implementing enhanced rescue readiness procedures. Instead of having a single rocket on standby for a launch-on-demand rescue, they are exploring a new strategy, keeping 2 backup modules partially assembled at any given time. This ready-to approach dramatically shortens the response time for any future emergency. This concept draws inspiration from both NASA's Apollo-era rescue planning and Russia's long, successful history of Soyuz emergency protocols. It's a hybrid strategy, taking the best ideas from around the world to create a more robust safety net. There's also one more fascinating development emerging from this incident. Sources indicate that China is now accelerating tests of a fully autonomous return capsule system. Picture this: a spacecraft capable of launching without a crew, flying itself to the Tiangong station and automatically docking to perform an emergency evacuation. If successful, this could become the world's first robotic lifeboat in orbit, a rescue vehicle available 24/7 for any crew in distress, regardless of their nationality. This technology could fundamentally change the calculus of space station safety. The legacy of the Shenzhou 20 and Shenzhou 21 missions is now clear. This wasn't just a rescue. It was a turning point, a near disaster that reshaped safety protocols, accelerated new technologies like AI-driven avoidance and robotic lifeboats, and pushed the global conversation on orbital hazards squarely into the spotlight. Most importantly, it showed us that even in the harshest, most unforgiving environment known to humankind, preparation, brilliant engineering, and international teamwork can turn a potential tragedy into a triumph of human ingenuity. As humanity pushes farther out, toward the Moon, Mars, and beyond, the lessons learned from this mission will travel with us. They will be etched into the technology that protects our explorers, embedded in the procedures that guide their actions, and carried in the spirit of every astronaut who dares to leave our home planet behind.